Hello, so welcome back to another video. Today we'll be looking at November 2018, question 5, still under functions for mathematics, grade 12, paper 1. Okay, so we're given a function, f of x is equal to minus 1 over x minus 1. So we already know that this is a hyperbola, right? It's in the form of a x minus x, let's just say x plus p plus q. Since this is negative, we already can predict our function to look like something like this, right? um, so this is 0. It means we don't have a our horizontal asymptote is y is equal to what, our horizontal asymptote, sorry, is x is equal to, it's y is equal to 0. Yes, it's the x-axis, and then these will be our vertical asymptote where it's x is equal to 1, right? Because we already know that these are our asymptotes, all right? And this shows us the shape of your hyperbola. Okay, so we can start answering. We're not given that much here, we're just given the graph, the function. So now we can start answering the questions, right? So question 5.1 asks us to write down the domain of f. So the domain of f, these are all values of f, all values of x for which the function f is defined, right? So we know that the function is not defined in the along the asymptotes, so only have one asymptote, which means that it's not defined along the horizontal, along the vertical asymptote, right? The vertical asymptote, as we can see there, is equal to 1, or we can do something different. For example, well, let's say we have all values of x, right? Value x is all values of real numbers, an element of real numbers. What happens if we substitute 1 here? We'll have a 0. Minus 1 divided by 0 is not defined. What does this mean? You cannot substitute 1 here, right? That's your domain. That's all. That's all. It's all values except 1. Okay, so we can just write from 5.1. Our solution is straight to the point. Actually, it's x is an element of real values. X is not equal to 1. Or what we can do, we can write x is an element of let's say negative to 1, right? So this is union, which is also OR. It's an element of what, 1 to positive infinity, or you can just write infinity. That's fine. So we can look at 5.2. So this is, I always recommend this, just write it like this. Don't confuse yourself by writing it like this, right? Just write it as x is not equal to the vertical asymptote. By the way, this is your vertical asymptote, right? You can also just look at the graph and look at values which are critical, which will not be defined, right? So let's see 5.2. Write down the asymptotes of f, so we can get down to that. Let's start with the vertical asymptote, which we have already talked about now. So x minus 1 is equal to 0, therefore x is equal to 1. The horizontal asymptote, our q is 0 now, so y is equal to 0. 5.3. Sketch the graph of f, clearly shown all intercepts with the axis and any asymptotes. So let's just do that very fast. Zoom out a little bit so we can have more space. Okay. Alright, let's just do this. Okay. Okay. Sorry. Let's grab another shape. we have y, we have x, right? The horizontal asymptote is at 1, so we can just indicate our asymptote like this. Let me just use a pencil with a dashed line. You can also just draw a solid line, it's okay. So this is our x is equal to 1. That's our vertical asymptote, because they say show all asymptotes. So for our function, what are our intercepts, right? So we can just get that quickly. We are given that minus 1, x minus 1. If we put 0 here, we'll have our y-intercept, because x is equal to 0 and 0 and 1. Because negative 1 and 1 is over 1 is 1. It's positive 1. So the x-intercept here, if we put the 0, we'll have that. So we'll have what? X minus 1 is equal to minus 1. Take this that side. So this is a plus. Let's see. This is a 0, right? Multiply this side. So we don't have an x. Oh, yeah. I don't know why I'm tripping. We don't have an x-intercept. Why? Because there's a vertical and horizontal asymptote along the x-axis. The x-axis is your horizontal asymptote, right? So you'll just have this. So let's just indicate it like this. So this is 0 and 1, right? Okay. So this is our horizontal asymptote here. So we are not supposed to cross the x-axis or x is equal to 1. So let's start drawing. So it will look something like this, right? Do not cross this line, just get close to it. Same thing this side, do not cross that line, just get close to it. Same thing here. I say do not cross the lines, just get close to it. Yeah, do not cross the line, just approach it. So this is what I have. That's our function. Our function what? F. Yes. So this is our function f, right? Okay. So we have showed all intercepts and horizontal asymptotes, and our asymptotes. I mean, so let's just go to 5.4 to see what we have. Okay, 5.4. For which values of x? For which values of x will x multiplied by the gradient of f be greater or equal to 0? Okay, so no need to stress. Let's just break it down. So it says for which values of f we have x and the gradient, which is f prime of fx, should be greater or equal to 0. When it comes to this, you just use signs, right? These are signs. It's very simple. Use your signs, because you cannot use the actual values, so you have to use the values of the signs of your values. For example, we need x values multiply. Okay, this is kind of confusing. Let's just use a dot multiplied by y values of f. They should be what? They should be greater or equal to 0, which means they should be positive or 0. Right, so let's look at signs. We know that a positive or a 0 number will come if we have a negative multiplied by a positive. We'll have something like this. So we need what? Sorry. A positive will come if you have like if you have the same signs, right? I wanted to say like charges. I don't know why. Physics is slipping through. So let's just go back to our function, right? So the question is, if you are given this, the function of f of x, you're asked to do something about that function. Are you supposed to differentiate the function f or what, and draw the graph of that function so that you can actually get Your answer, no. You look at your graph. So there's something called the decreasing or increasing function. So we know that gradient, let's just write this, gradient is equal to what? Change in y over change in x, right? And this change is positive, and also this is positive, or the change is negative and also this is negative. What do we expect? A positive, right? A positive gradient. So if you are moving in this direction, your x values are increasing, your y values are increasing, right? So what do we have? We have a positive change in y, a positive change in x. So it means you have an increasing function, right? If you were moving in that direction, now you are moving in that direction, your x values are decreasing, so this is negative, right? And you are moving what? Up in the y direction, which means this is positive, so this is a decreasing function because these signs don't match at all, right? So how can you show that? We can look at this function here. This one, it's increasing, it's an increasing function. This one, it's an increasing function. How do we see it? We see it like that. So this is was as the x values increase, the y values are also increasing. So you just have positive, you can put positive signs, positive signs, positive signs. So let's look at this other side. You also have positive signs here, right? Because we want to look at our gradient. So this is our gradient. Our gradient is positive. We don't need the actual value, but rather we need the signs. So for the x values, the x values are negative in this direction because it's less than 0, and then here they become positive, you have positive, right? So let's just see here in this direction where you have x less or equal to 0, these two signs are opposite, so you have a negative product. So this, you don't have a solution here. Okay, then what about between these two? Oh yeah, you cannot have x equal or to 1. You cannot have it equal to 1 because that's an asymptote. I forgot about that. Don't fall for that. So here, the x values are positive, the gradient is positive. You do have a solution in between here. So after the asymptote, where you just have x is greater than 1, positive gradient, positive x values, we have a solution. So your solution, therefore, you can write x is less than 1, greater or equal to 0, or x is greater than 1, or x is greater than 1, but x is not equal to 1. Oh, sorry, x is greater or equal to 0, but x is not equal to 1, right? Because you have a solution from here to that side, but you have a vertical asymptote here. So your graph is not defined here, so you can't have a solution here. So you have to exclude minus, you have to exclude x is equal to 1, right? So your solution will look at I'll always prefer this, writing it like that, but you can also write it like this, right? It depends on preference. As long as you understand what you're writing, right, then you'll be fine. So that's all we have for this question. It's that simple. I think this one 5.4 will be the one that needs your attention more to actually understand it, because these questions are a little bit complicated, right? But yeah, with practice it becomes easier. And if there are any questions, suggestions, or feedback, please do drop a comment, like, subscribe, and share. Thank you very much.